So this is a continuation of our limiting reactant notes. So we call it limiting reactant problems. Sometimes limiting reactants are called limiting reagents. So you may see that here and there just with some of the terminology. All right. So we're going to start out with our balanced equation. 4Fe plus 3O2 gives you 2Fe2O3. So we have our balanced equation, and here's our problem. If we have 10 moles of Fe and 7 moles of O2, how many moles of Fe2O3 can be made? So what's different about this type of problem is that you have two ingredients and you want to know how much product you can make. And that's going to be the way that you identify a limiting reactant problem. And so, sort of like we did with s'mores, we said we're going to have to take each of our ingredients and figure out how much product can be made. All right, so we're going to start out with one equation is going to be 10 moles of Fe. And we're going to convert to moles of Fe2O3, all right, moles of our product. And our second equation is going to be 7 moles of O2, and we're going to convert that to moles of Fe2O3. So this is going to be a moles of A to moles of B problem, so it's going to be a one-step problem. And so to cancel our units in the first example, we're going to put moles of Fe on the bottom. Okay. All right, so we have moles of Fe on the bottom, and we're going to put moles of Fe2O3 on the top. And again, when we're converting moles A to moles of B, the only place we see those related to each other is the equation. So from the equation, I'm going to put a 2 in front of moles of Fe2O3. And for Fe, we're going to put 4 down the bottom. So this should work out to about 5 moles. All right, 10 times 2 divided by 4, you can reduce. So what this calculation has told us is that if we have 10 moles of Fe, we can make 5 moles of our product. Now we're going to figure out if we have 7 moles of O2, how many moles of product can we make? We'll solve it the same way with moles of O2 on the bottom and moles of Fe2O3 on top. And again, from the equation, we're going to put 2 moles, that's the number in front of Fe2O3 in our equation. And for the bottom, we're going to put 3. When we do the math, we take 7 times 2, divided by 3, we should get about 4.7 moles of Fe2O3. Now, when we look at these two amounts of product, are we going to make the bigger amount of product or the smaller? Smaller amount of product, very good. So I'm just going to circle this to indicate that I'm going to make the smaller amount of product. And we're always going to make the smaller amount of product because in this case, the oxygen will run out first. So even though it didn't ask us, we can go ahead and list this and say oxygen is the limiting reactant. Oxygen is going to run out, and when we look at our equation, when we run out of oxygen, this reaction will stop. Because one of the 2 ingredients that we need stops. Just like in s'mores, when we said that that when you run out of chocolates, you can no longer make s'mores. Okay? All right. We're going to use the same equation and just make this a little bit more complicated. just slightly. And so we're still going to have 4 moles of Fe plus 3 moles of O2. We're going to go to 2 moles of Fe2O3, so we'll use that same equation. And so let's say that we have, if we have 100 grams of each reactant, how many moles of Fe2O3 can be made? So this is, again, is a limiting reactant problem. And when we're trying to identify it and say, what strategy should I use to solve this problem, we want to recognize that we're given a certain amount of each of our ingredients. It's written a little bit differently than the previous problem, but that's what we want to recognize. So once we recognize that, we're gonna need to use 2 equations here. All right. So let's see. So I'm going to start out with 100 grams of Fe, and I'm going to convert this to moles of Fe2O3. So here's one of my given information, 100 grams of Fe. And my second one is 100 grams of O2. And again, we're going to convert to the same product here, Fe2O3. So when we approach these, now it's a grams of A to moles of B type problem. So we go from grams of A, we convert to moles of A, and moles of A to moles of B. And that's going to help us solve this. So in the top example, to cancel grams of Fe, we know we have to put these same units on the bottom. And the advantage of writing sort of this path on the top is that the units that I have on the top, like moles of A, that tells us what's going to drop down in this spot. So I got moles, and our chemical A is Fe. That's what we started with. When I have moles and grams related, we know that has to do with molar mass. So for every 1 mole, looking on my periodic table, I find the molar mass of Fe is 55.8. Your grams of Fe are going to cancel. And now we're left with moles of Fe, which we don't want. We want moles of our product. So we'll cancel these out. We'll put moles of Fe on the bottom. And moles of our chemical B, and our chemical B is our product there, go on top, Fe2O3. Moles of Fe2O3. From our equation, I see 2 moles of Fe2O3 and 4 moles of Fe. Okay. When we do the math on this, we should get about 0.9 moles of Fe2O3. All right, approximately. I didn't carry out significant figures here or anything like that. Okay. So what we're saying is if we have 100 grams of Fe, we can make about 0.9 moles of our product. We're going to figure out we're going to do the same process through our other ingredient. So we're going to put grams of O2 on the bottom for every 1 mole of O2, converting grams of oxygen to moles of oxygen. 32 is your molar mass because oxygen is diatomic. There's 2 oxygens here, so 16 times 2. Grams of O2 will cancel. And we now need to cancel moles of O2, so we put those on the bottom. And what we'll notice in limiting reactant problems is once you have sort of what you have at the end, where you know you're going to sort of stop your calculation, whatever's on top in the first reaction is going to be on top in the second reaction. Or second calculation, I should say. So 2 moles, and this is coming from the equation, and for oxygen it's 3 moles from our equation. When we do the math here, we get about 2.1 moles of our product. And again, once we figure out how much product can be made from each ingredient, we ask ourselves, are we going to make the bigger amount or the smaller amount of product? Smaller amount. And that also tells us that Fe is our limiting reactant because the iron, the Fe, makes a smaller amount of product. So it makes a smaller amount of product because it gets used up first. And those two ideas, that it's going to run out first and therefore limit the amount of product, those are the key ideas about limiting reactants.